So recall that in order to resolve the conflict, the partial order planner has decided to promote this goal over that one. As it tries to connect these two plans, it finds that there is an open condition problem that we just talked about. On robot ladder does not match on robot floor. So now it needs to select an operator whose post condition will match this state, robot on floor, and whose preconditions will match this state, robot on ladder. And there is just one operator that matches those conditions. And that operator is descend ladder. So now the partial order planner uses this information to select the operator descend ladder, and now we have a complete plan. So now you know about the algorithm for partial order planning and how it works in practice. But what does this tell us about intelligence? Let's consider several postulates. First, knowledge is not just about the world. Knowledge is also controlled knowledge. That is often tacit, but this controlled knowledge helps us select between operators. Second, that goals provide controlled knowledge. Goals can be used to decide between different operators, and we select an operator that helps us move closer to the goal. Third, we can view partial order planning as an interaction between several different kinds of agents or abilities. Each agent here represents a small micro ability. There is this agent which was responsible for generating plans for each of the goals independently. Then there was an agent responsible for detecting conflicts between them. Then there was a third agent responsible for resolving these conflicts. So we can think of partial order planning as emerging out of interaction between three different agents, each one of which is capable of only a small ability. So we can think of partial order planning as emerging out of interaction between three agents, where each agent is capable of only one small task. Minsky has proposed the notion of a society of mind, a society of agents inside an intelligent agent's mind that work together to produce complex behavior, where each agent itself is very simple, as in this case, a simple agent for detecting conflicts, a simple agent for resolving conflicts, and of course an agent for making simple plans for simple goals. There is one other lesson to take away from here. When you and I solve problems like the ladder and the ceiling problem, we seem to address these problems almost effortlessly and almost instantaneously. So it looks really simple. What AI does, however, is to make the process explicit. To write a computer program that can solve the same problem is very hard. It is hard because the computer program must specify each operator, each precondition, each state, each goal, every step very, very clearly and very, very precisely. By writing these computer programs, these AI agents that can solve this problem, we make the process that humans might be using more explicit. We generate hypotheses about how humans might be doing it, which is a very powerful idea.